Good morning students. Chapter 6 Electromagnetic Induction. In last lecture we have discussed about Faraday's law. Faraday's law which gives induced EMF. Okay, induced EMF, magnitude of induced EMF is equal to time rate of change of magnetic flux through that circuit. And yes, Faraday's law gives magnitude of induced EMF, and from that we can find magnitude of current. But how to find direction of induced EMF? How to find in which direction current is produced, in which direction current is generated? That is given by Lenz. That is given by Lenz. What is Lenz law and what is conservation of energy? That we will study with the help of one example. Suppose it is one coil connected to galvanometer and with some resistance R, if it is R. Okay. Now with this coil, if we have one magnet, it's north pole this side, here it is south pole, and if we bring this magnet towards this coil facing its north pole, yes or no, it is a situation. You are given a coil which is connected with galvanometer and external resistance. One magnet having north pole facing this coil is moving towards coil. Yes or no? Is moving towards coil. Okay, so yes, as magnet is moving towards coil, magnet is moving towards coil. So yes, distance between them decreases. So yes, distance between them decreases. So yes, magnetic field linked with this coil increases. Yes or no? Magnetic field increases. So yes, flux through coil, that is phi, increases. Simple. Magnet is moving towards coil. R increases, magnetic field increases, magnetic flux through coil increases. Simple. Yes or no? Yes, it is. Now, due to this flux through coil increases means there is change in flux. Means there is change in flux. There is change in flux. And due to change in flux, EMF is induced. Due to change in flux, EMF is induced. And due to induced EMF, current is generated. Due to induced EMF, current is generated. Simple? Yes or no? Yes. This magnet is moving towards this coil. Yes. So distance decreases. We know that due to that magnetic field increases. Flux through coil, that is phi, increases. Due to change in flux, EMF is induced and current is generated in coil. Now question is, in which direction current is generated? How EMF is induced so that it produces current in which direction? Okay, so yes, here first alternative I am assuming okay, when I am observing coil from this point, okay, from this in this direction of motion, and if current is flowing in this coil is in clockwise direction like this, clockwise direction, then we know that when current is flowing in clockwise direction, current is induced in this direction. Okay, first explain that current is induced in clockwise direction. direction. When we observe from this side, yes or no? Clockwise direction. Wrap your fingers, thumb will go inside. So this pole facing magnet, it behaves as south pole. Then. Okay, yes. This coil, as current is produced, it behaves as a magnet and south pole is generated. It is facing this north pole. Yes or no? That current is induced in clockwise direction. Current is induced in clockwise direction and let south pole is generated. South pole is generated. Clear about this? So yes, current is flowing in clockwise direction. That we have assumed. We have assumed. Okay. Collapse current is flowing in clockwise direction. So this pole behaves as south pole. This pole behaves as south pole. This pole behaves as south pole. Okay, pole behaves as south pole. Facing magnet. Clear about this? Now, it is north pole, it is south pole. So between north pole and south pole there is attractive force. Between north pole and south pole, there is attractive force. Between north pole and south pole, there is which type of force? Attractive force. Yes, it is attractive force. So when there is attractive force, if I give a gentle push, a very small force, this magnet will move due to attractive force towards south pole. Yes or no? If I give a small push, this magnet will move towards the south pole with accelerated motion due to attractive force. Clear about this? If we apply very small force, yes, magnet moves towards coil due to attractive force. Yes or no? It is moving due to attractive force, and as it is moving, distance decreases, magnetic field increases, flux through coil increases, flux changes, EMF is induced, current is induced. And yes, current is flowing in this coil. So that current is passing from this resistance. Yes or no? If resistance R is connected in coil, then heat or energy generated is I square RT. Yes or no? We will have some heat energy in this coil. But what is work done on magnet? Nothing. What is work done on magnet? Nothing. This magnet is moving towards this coil due to attractive force. Without any work, we have to give just a very small force, negligible force. This magnet will move towards this coil due to attractive force. So here without any external work, we have heat energy generated. Without any work done, we have heat energy generated. Is it possible according to law of conservation of energy? No. It is not possible according to law of conservation of energy. Because without any work you have energy. It means you can make numbers of instruments You can make numbers of instruments in which without any work you will get energy, without any work you will get energy. Then simple. Okay, best life. Without any work we have to produce energy. Without any work we have to produce energy. So it is violation of law of conservation of energy. It is not possible. It is not possible. According to, it is not possible according to law of conservation of energy. Law of conservation of energy. Clear? It is not possible means this assumption is not possible. Okay, that current is induced in clockwise direction. This assumption is wrong. This assumption is wrong. Then which assumption is right? Yes, here we will discuss which assumption is right. See here it is. See here which assumption is right. If see here it is coil. Again same coil connected with galvanometer, connected with some resistance R. Okay, if it is magnet, it is north pole, it is south pole, it is moving towards coil, then which assumption is wrong? That current is induced in clockwise direction. Now we have raised if current is induced in anti-clockwise direction, like this. So yes, we know that it behaves as north pole. Okay, now let current is induced, in anti-clockwise direction. In anti-clockwise direction. Then side of coil facing magnet behaves as north pole. It behaves as north pole. Clear about this? Then side of coil facing magnet, it behaves as north pole. So now think about this. It is north pole. If in this coil magnetic field produced is such that it is also behaving as north pole, then between north pole there is repulsive force. Yes, between two north pole there is repulsive force. So now in this situation, if we want to move this magnet towards coil, we have to do some work. Now as this side of coil behaves as north pole, magnet, its north pole is facing coil. So if we want to move this magnet towards coil, we have to do some work against this repulsive force. Yes or no? Yes. So now work is done. We have to apply some external force. Okay, work is done on magnet to move towards coil against repulsive force. Clear about this? So now we have to do some work. We are doing some work. This magnet is moving towards coil. Again the same flow. Distance decreases, magnetic field increases, flux increases, change in flux, EMF is induced, current is produced in this circuit, and current is produced. So in this resistance, okay, heat energy produced in coil. Is I square RT. So now we can say we have done some work, and due to that work, that energy is stored. Yes or no? Yes. Here, without any work done, we got energy. Without any work done, we got energy. But here, we have done some work on magnet, and due to that, we have some energy produced in coil. So yes, it is law of conservation of energy. Okay, energy, it remains constant. It can be transformed from one form to another form. It is converted from one form to another form. It is not generated or it is not destroyed. Clear about this? So yes, heat energy produced in coil is I square active and is due to work done. And is due to work done. Okay, if we do work, then energy is produced. If we do work, then energy is produced. So yes, it is law of conservation of energy. It is here law of conservation of energy is obeyed. Okay, here law of conservation of energy. Law of conservation of energy is obeyed. So our this alternative is right and this alternative is wrong. So now how to make statement? See, this north pole is facing this coil and moving towards. Yes or no? So in this coil EMF is induced such that current produces in such a direction that opposes change in flux. How change in flux? See, again remember this topic. We are moving this magnet towards coil. Distance decreases, magnetic field increases, flux increases. Yes or no? And due to that increase in flux, here EMF is induced, current is induced such that it opposes change in magnetic flux, that is increasing magnetic flux. So what is Lenz law? Yes, statement is somehow confusion. Okay, yes, what is Lenz law? EMF is induced such that it opposes its cause. EMF is induced such that it opposes its cause. Here, EMF is induced such that it opposes its cause. Which produces it. Okay, so now how to write statement of Lenz law? See, now how to write statement of Lenz law? The polarity of induced EMF is such that it tends to produce a current which opposes the change in magnetic flux that produced it. What is meaning of this? See, again, here it is coil. Okay, this magnet is moving, facing north pole towards coil. It is moving in this direction. Yes or no? As this magnet is moving towards coil, distance decreases, magnetic field increases. Due to that, flux in this coil increases. Yes or no? Yes. Okay. Magnetic flux, as magnet is moving towards coil. Magnetic flux in coil increases. So therefore EMF is induced such that current is produced which opposes this magnetic flux. Opposes, it means magnetic flux in coil increases. To oppose, it means here current is produced such that now flux linked with this coil should be decreased. And when it decreases, when this pole behaves as north pole, when this pole behaves as north pole, so there is repulsive force. Due to repulsive force, this magnet will try to move in opposite direction. It will try to move in opposite direction. Opposite direction means distance increases, magnetic field decreases, flux decreases. So it is meaning EMF is induced such that current is produced which opposes this magnetic flux. Initially, what is cause? Cause is magnetic flux increases, and due to that cause, EMF is induced such that it opposes this magnetic flux. Means now current is induced such that it opposes its increasing flux. Clear about this? Similarly, if it is magnet, south pole, north pole, it is coil. Now magnet is moving away. Means distance increases. It is second case. Now magnet is moving away. Away means distance increases, magnetic field decreases. Yes or no? So magnetic flux also decreases. If magnet is moving away from coil, magnet is moving away from coil. Magnet is moving away from coil. It means magnetic flux in coil decreases. Magnetic flux in coil decreases. So now magnetic flux decreases, change in flux. EMF is induced in this coil. EMF in this coil is induced such that current is produced such that it opposes its cause. Means now current is produced such that flux increases. So this pole behaves as south pole. And current flows in clockwise direction. So now there is attractive force between north and south. Attractive force means magnet will move towards. See, in opposite direction. Magnet will move towards. Cause is magnet is moving in this direction. It is cause. Magnet is moving in this direction. Due to this motion, magnet is moving, that is away from coil. Magnetic flux in coil decreases. Here EMF is induced. Current is produced such that it behaves as south pole. And this magnet is attracted towards this south pole. So yes, here again EMF is induced such that current is produced which opposes this magnetic flux. So simple. EMF is induced such that it opposes its cause. EMF is induced such that it opposes its cause. And now you may understand that negative sign, that is E is equal to minus d phi upon dt. EMF is induced such that it opposes change in flux. EMF is induced such that it opposes change in flux. Clear about this? So if flux is increasing, that is cause, then EMF is induced such that now flux decreases. Okay? So yes, it is negative sign indicates presence of Lenz law. Negative sign indicates Lenz law. Okay, so the title is Lenz law and conservation of energy. Clear about this? So yes, it is one theory. That is what is Lenz law. And yes, this Lenz law gives direction of induced EMF and induced current. It gives Lenz law. It gives direction of induced EMF. Okay, and it is based on law of conservation of energy. law of conservation of energy. Okay, so yes, these points are for MCQ part. Clear? So yes, dear students, chapter 6, electromagnetic induction, it is Lenz's law, one important theory, and yes, statement, it may confuse you, okay, but yes, it is statement, okay. So yes, students, as you are in 12th, yes, watch videos regularly, make notes regularly. If you have any doubt, then contact on my number, that is 75748580001, and yes, do like, share and comment our videos.